Okay, so if we take a look at a different question now of combining what we just did with the earlier things in this section. So just a brief recall of what we just did in our last video. We said that the possible rational zeros of x cubed plus 4x squared minus 9x minus 36. This is the whole list of all of these plus or minuses. Okay, now the question that we'd like to ask then is that which are zeros, right? These are possible zeros, but as I've said over and over again, this is not all of the zeros, right? This doesn't make sense. You can't have all of these be the zeros of this. So only some of them, maybe none of them will work. So we'd like to figure out how do we check this. So how do we figure out which one of these are zeros? Well, unfortunately, it comes to guess and check. So all we basically are going to do is we're going to check each and every one of them until we find one that works, right? So you could, you just try all of these if you want to find out which one of these are all zeros, but we're going to use a slightly faster way. So we're going to at least try to find one of them right now. So you just simply try each of these. You evaluate your function at each choice. So let's try one first. You plug in 1 into this, you're going to get negative 40. If you instead try plugging in negative 1 into this and simplifying, you're going to get negative 24. If you plug in the next choice of 2, you plug that in, you're going to get negative 30. F of negative 2, you plug all of that in and you're going to get negative 10. Now at this point you're like, I've been doing a lot of work, but hopefully it's all calculator work to see this. Don't give up, just keep trying and keep trying. So then we try the next one, f of 3, we plug 3 into this, we get 0. So hooray, what we have shown is that we see x equals 3 is a 0. So you could keep checking all these other ones, but we're going to find a faster way now to figure out what are all of the zeros of this now that we know one of them. So if we go over here, we're going to take a look at this question. So now we're going to completely factor f of x equals the same thing using the factor theorem and division. So remember, the factor theorem, that says that if we have a 0, we know a factor, or if you know a factor, you know a 0. So what we have is that we have ourselves a 0 of this polynomial. So for this, we know that x equals 3 is a 0. That's great. Now we know a 0. Now what we just did in the previous video is we could now use this 0 to do some division. Right, so if we know x equals 3 is a 0, what this implies is that x minus 3 is a factor. So we're going to be writing this as x minus 3 times something else. Right, so remember when we factor, we're writing it as things being multiplied together. So we're going to write this as x minus 3 times something else. How do we figure out what that something else is? Well, this is where division comes into play. So we're going to look at x cubed plus 4x squared minus 9x minus 36 divided by x minus 3. So we'd like to figure out what is this equal to. Well, now we do whatever type of division you prefer, synthetic or long division. I, again, prefer synthetic division when I can use it. So we form our little box. In the box, the number is the one that makes our denominator equal to 0. So that's going to be 3. Notice that's the same as the 0 up here, right? It will always be that way. So now I put 1, 4, negative 9, negative 36. And then I bring down my first number here. I bring down the 1. I multiply, and then I add. I multiply to 21, and then I add to 12. I multiply to 36, and I add to 0. Now again, remember, this always, always, always should be 0. Our remainder should be 0 when we know something is a factor. So if it's not a factor, then this won't be 0, but it is because we said that by the factor theorem. We know that this is a factor. So again, remember, these are the coefficients of x's of a degree less than this. So this is now an x squared. So this is going to be x squared plus 7x plus 12. So writing it now In more of a factored form, we see that x cubed plus 4x squared minus 9x minus 36 is equal to x minus 3 times x squared plus 7x plus 12. So this is now starting to look a lot more like it's completely factored, but there's still one step left. We have to try to factor this one step further. So we figure out what multiplies to 12 and adds to 7. Well, that's going to be x plus 3 times x plus 4. Now, an important note is that if we couldn't factor this further, if our regular factoring techniques doesn't work, we could use the quadratic formula. We could go ahead, find the zeros of this, and then use the factor theorem again. That now we know zeros, we know factors. So if you know the quadratic formula, you could use that as well to simplify this. So this is what it looks like completely factored. But then again, remember that once we know these factors, we also know the zeros too. So now we know that the zeros of this would be plus or minus 3 and negative 4. Because each of these, if x plus 4 is a factor, then x equals negative 4 is a 0. So we now have a list of what this looks like fully factored, and we have a list of all of the zeros. So what that means is if you went back over here, in this case, all of our zeros actually were rational numbers. It's not true always, but indeed, you could have found any of these to begin with, and then done your long division or done your synthetic division to be able to fully factor this.